So section 1.3 is called compound interest, and it talks about future value in the textbook. Really, it's the formula. We're going to be looking at the formula, and I'm just going to spend the first little bit of the lesson developing this compound interest formula. And what we do is we start with the simple interest formula. Okay, so from section 1.1 and 1.2, where we talked about that formula, we're going to start with that. This is the one that we've been using, but if you recall, there is another version of this where this p that's in both terms basically gets factored out, and you have a, that's the future value, equals p times 1 plus r times t. So this is the version of the simple interest formula that we're going to start with, so that we can develop the compound interest formula. Okay? So I'm just going to get rid of this one for now. We're not going to use that one. Keep that in your notes there. But I'm just going to slide this up, and we're going to take a look at this formula. Now in your textbook, you should be open to 1.3, which it is here. Let's look together at this first example under the Learn About the Math. Okay? So it says this: Yvonne earned $4,300 in overtime on a carpentry job. So there she is doing her carpentry there. She invested the money in a 10-year CSB that will earn 3.8% compounded annually. All right, so again, we're talking about compound interest because the word compounded is there. And it's compounded annually, that's one time per year. And those are the examples that we did in 1.2. She decided to invest it in a CSB instead of keeping the money in a savings account, because the CSB will earn more interest. The question is, what's the future value of Yvonne's investment after 10 years? And this is sort of what we've been doing. I guess in 1.2, this is what we're doing, and this is the connection between kind of the long method, or the chart method, and the formula. So if we go back to the notes here, I've just got this page clipped out. So here's the page of the solution. Now, notice down here, okay, that we have a principal of $4,300, right? That's the p value right here, and so there it shows up in our formula. Now this is we're calculating the interest at the end of the first year, okay? And so this is just like a simple interest question if we're talking about the first year, because it's not compounding yet. So there's our principal. 3.8% is the annual average. Okay, so 3.8%, and that goes here in the formula. Now remember, it's a decimal form of the percent always. And the t, if we're looking at 1 year, then the t value, we're talking about 1 year, the first year. So all in all, this is the amount of money that will be made at the end of the first year. You should remember this from yesterday's lesson. Okay? So I want you to notice a couple things here. The couple things I want you to notice is this, that this is just like simple interest. And with this new formula, the new version of the formula, look at this. This right there, 1 plus 0.038 times 1, is actually 1.038. And you're going to see that come up again and again. So that's after the first year. What about the second year? Well, the second year, we take this dollar amount, right? The money that we have at the end of the first year, that becomes our principal right here. And that's the big difference now between simple and compound. And notice that this 1.038 shows up again. So we take the new value times this for the second year. Third year, we take the brand new value here, and we multiply it by, where is it, 1.38, 1.038. So you see a pattern here. We're taking the money from the previous year, multiplying it by 1 plus the interest rate for each year's interest. Now the interesting part comes down here when you see this little chart. So in the margin there it says, and this person that was doing the question, I used the diagram to show the pattern for how basically the values come up each year. So after 1 year, pretty simple. The original amount times 1.038. The second year, it's this times another 1.038, because this times this equals that. And then times 1.038 again, and so we've really taken the principal and we've multiplied it by 1.038 3 times to get the money after year 3. So there's a pattern here, and the pattern is what we're going to explore, and that's what's going to become the formula. So how many times is this going to happen? Well, it's a 10-year thing, so we're looking at 10 times that this is going to happen. And so our formula sort of becomes this: A equals the principal times 1 plus the interest rate, okay, yearly interest rate for now. And then this is actually happening. We multiply it by this 10 times, okay? So we're going to have, in this case, n is the number of times that the interest is calculated, okay? So let me just expand this out. So watch this. A equals, in this case it was 4,300 times 1.038 times 1.038 times 1.038. Now that's after 3 years, so after 10 years you see how this would be multiplied 10 times? And another way of writing this multiplied by itself 10 times is this. Just the value itself to the power of 10. Okay? So that is the development of the formula. You can go over this again if you need to. But the right here, this is the compound interest formula when the interest rate and the compounding periods, okay, are yearly. So well, if they're not yearly, I'm going to talk about that later. That's coming next. Okay. So again, here's the summary. This is what has happened. Okay, 4,300 times 1 plus the annual interest rate times the number of years. Okay, and that turns into this formula right here. Okay, couple things I want to go over with this new formula. One is the n. Okay, n is the compounding period. So that is how many times does this interest get calculated? And in this case, it's once per year for 10 years. So that is 10 times. You see that? That's where this 10 comes from. The other thing I want to talk to you about is the I. Notice how this is a little I now and not an R. Because before it was, where was it? See, look at, before it was an R. You see that? RT? I know it's small, but see that? So what's the difference between R and I? Well, I is the interest rate per compounding period. That means if you have an annual interest rate and it compounds once per year, then R equals I. But if the compounding period is more than one time of year, then I changes. So this chart is actually in your textbook as well. It's on page 29 if you want to go there. But this is a little explanation on where we get N from and where we get I from. Okay? So remember our formula here is A equals P times 1 plus I to the power of N. This is our compound interest formula. You need to write that down if you don't have it yet. Compound interest formula. And the chart below here is a little explanation on how we come about I and N for any situation. Alright, so the compounding frequency, that is, the frequency means kind of how many times it happens, how many times does the compound interest get calculated. If it says annually, that's once per year. So that's once per year, and I is equal to the annual interest rate in that case. And the number of compounding periods is simply the number of years that of the term. Okay? Semi-annually, right here, semi-annually is 2 times per year. So semi kind of means half. So if it's compounded semi-annually, it's compounded every half a year. Now, this is where the I changes. The I is the interest rate per compounding period, so it's the annual interest rate divided by 2, because it's semi-annual, 2 times a year. See that? And the number of compounding periods is 2 times per year, so the number of years times 2. So it's important for you to be able to calculate I and N. Super important. So that's what we're going over here. Okay. Quarterly is 4 times a year. You know, a quarter is 1 over 4, right? So it's 4 times a year. And the I value there is the annual interest rate divided by 4. And the number of compounding periods would be 4 times for every year, or the number of years times 4. Monthly, obviously, is 12 times per year, so annual interest rate divided by 12. And the number of years times 12. What about if it said daily? How many times per year if it was compounded daily? Because credit cards, if you guys are using credit cards, okay, which they're the most awesome things in the world, right, so far, unless you have credit card debt. But some credit cards, they compound daily. So like every day, they calculate interest. Say, what do you got in there? Oh, let's take some interest off there, right on. And let's add that on so we can calculate that again tomorrow morning. And it goes sky high pretty quick. So you got to be real careful with credit cards. In Chapter 2, we'll talk more about credit cards, like the pluses and the minuses, what to watch out for. Okay? Credit cards are really cool if you pay them off right away. So you got to be real careful. Anyways, daily is 365 times a year. And I is the interest rate R divided by 365. And N is 365 times the number of years. Okay, pretty straightforward, right? Okay. So let's take a look at an example in your textbook here. Okay, on page there. Here it is. Example 3. Okay, and this is on page 24 of your textbook if you're following along. And let's take a look at this question, because this question really helps us to understand compound interest. And it also is very, very good for you guys if you have some money, any money at all, and you can put it away and not touch it. It'd be a good idea to do that, because compound interest can really work in your favor if you have some money that you can put away now. Most of you, I know, don't have any money. Well, actually, most of you have a higher disposable income than me, probably. You're making less money, but you're also paying a lot less for everything. But anyways, if you have some money that you're not setting aside for school or for, I don't know, shoes or for muscle shirts or I don't know, whatever else you guys are planning to buy here. Yeah, I know. Muscle shirts, I know. But anyways, if you have some money that you can like put in the bank or put away for a little while, this is a good example for you to consider. Okay? So it says this: determine future value of investments with monthly compounding. So we're going to use our new formula, calculate I and N and all that sort of stuff. Okay? So let's take a look at it. Both Jolie, age 50, and her daughter Lena, age 18, plan to invest the same amount of money, that's $1,500, into an account with an annual interest rate of 9% compounded monthly. Okay? So the mom and the daughter putting money in the bank. If both women hold their investments until age 65, what will be the difference in the future values of their investments? So this is what I want to focus on. A mom and a daughter both putting the same amount of money away, same account. Watch how compound interest works, guys. Okay, so check this out. There's a little bit of a diagram. Jolie, the mom, $1,500 at age 50. Okay, so she's going to go on for 15 years. And we're going to check out what her money's worth then. Lena's investment starts at 18. If she's able to leave it in there